Hi everyone, welcome back to the Big O series. Today we're talking about exponential time complexity, written as O of 2 to the power of n. This means the runtime grows exponentially with the size of the input. For every extra element we add, the amount of work can roughly double. To make this idea more concrete, we'll use a classic example, the power set, which is the set of all subsets of a given collection. So what exactly is a power set? Let's say we have three characters, A, B, and C. The power set is simply every possible combination of these elements. That includes the empty set, the single element sets, A, B, and C, the two element sets, AB, AC, and BC, and finally the full set, ABC. Altogether, there are 8 subsets. In general, if a set has n elements, its power set will contain 2 to the power of n subsets. Let's first look at a very intuitive solution called the bitmask method. Here, we use the binary representation of numbers to decide whether each element is included or not. A 1 means the element is chosen, and a 0 means it's not. Here's the Python version. The expression 1 shifted left by n calculates 2 to the power of n. Each number I represents a unique selection plan, and the binary digits of I show which elements are picked. The outer loop goes from 0 up to 2 to the n minus 1, and the inner loop checks each bit. If the bit is 1, we include that element in the current subset. Each number corresponds to exactly one subset, so we get 2 to the n subsets in total. That's why the time complexity is O of 2 to the power of n. Now let's look at the recursive version. The idea is simple. Each element has 2 choices, either to be included or not. Take the set A, B, C as an example. The recursion starts from the empty set. First, it decides whether to include A or skip it. Then, along each branch, it makes the same decision for B. Finally, it does the same for C. This forms a recursion tree that explores every possible path. Since each element doubles the number of possibilities, we end up with 2 to the power of n subsets in total. The time complexity is still O of 2 to the power of n. Let's wrap up with a quick reality check. The power set is an exponential algorithm. If we could generate one subset per millisecond, then for n equals 20, it would take about 17 minutes. Jump to n equals 30, and that's already 12 days. Push it to n equals 40, and you're looking at an unbelievable 34 years. This shows that O of 2 to the n algorithms are fine for learning and for small inputs, but they're completely impractical on large-scale data.